Welcome to today's episode of Buildings Hub Live, where we spotlight the changemakers and technologies leading the charge to electrify our built environment. On our podcast, we tackle the issues facing building decarbonization, from space heating to electric cooking to building codes and beyond. On this episode, we'll chat with David Calabrese, Senior Vice President of Government Affairs at Daikin U.S, and Jane Melia, CEO of Harvest. How are innovators making heat pumps more efficient at heating and cooling your home? Stay tuned to find out. Here's your host, Atlas Public Policy Analyst, Stephen Naimoli.
Good afternoon, everyone, and welcome to the 20th episode of Buildings Hub Live. My name is Stephen Naimoli, Policy Analyst at Atlas Public Policy, and I have the honor of being your host today. For today's episode, we'll discuss innovation in heat pumps. What new solutions are companies bringing to market to revolutionize how we heat and cool our buildings? Stay with us to find out. Before we jump into our discussion today, a quick note on Buildings Hub. Here at Atlas, we manage a one-stop shop data analysis tool for building sector electrification called Buildings Hub. If you're interested in heat pump market data, state buildings policies and funding programs, the current makeup of the U.S. housing stock, and crisply designed dashboards, we've got you covered. We'll soon be posting a data story looking at how to measure the legacy of state buildings policies. We encourage you to register for our platform and check out our data features. We'd love to have you join the Buildings Hub community. As for this episode, we're currently live on YouTube and LinkedIn. We encourage our audience to send your questions via the Q&A portal on our YouTube live stream, and we will work them into the discussion. We look forward to hearing from you throughout the episode. It's now my pleasure to introduce our special guests today. We are joined by David Calabrese, Senior Vice President of Government Affairs at Daikin U.S, and Jane Melia, CEO of Harvest. David and Jane, thank you so much for being here with us today.
Thank you.
Thank you. It's a pleasure to be here.
We've got lots to cover in only half an hour, so let's get right to it. To start off, please just tell us a little bit about your role and your company. David, we'll start with you.
Sure. Yeah, thank you. So I'm Dave Calabrese, Senior Vice President for Government Affairs with Daikin U.S. Corporation here in the Washington, D.C. office. My job really is to oversee our government affairs, government relations activities, focusing on those policies supporting innovation, energy efficiency, and sustainable HVAC solutions. Daikin, many of you may not know, we're a global company. And actually one of the largest, the largest HVAC company in the world. In our presence here, though, in the U.S., we have 22,000 employees, 70,000 employees globally. And we really see our role to promote those sustainable solutions that provide the best comfort, but also addressing the challenges that we face today with the environment.
Great. Thanks, David. Jane, let's go to you.
Absolutely. So it's great to be here. So I'm Jane. I'm the CEO and co-founder of Harvest, and my role, of course, is to build and grow the latest technology to help heat pumps get even better. I love the title of this webinar: New Innovations Making Heat Pumps Even More Efficient. Heat pumps are fantastic devices, but there's room to grow, and we're not standing still, so that technology is improving. And so what are we doing? What Harvest is doing is taking high performance air to water heat pumps, combining them with thermal storage, combining them with smart controls to really address some of the challenges to scale that are costs and grid impact. And I look forward to telling you more about that in a few minutes.
Great, thank you. Well, let's stick with you, Jane, on my next question, which is, what is the innovation that sets Harvest apart from others?
Great question. So first of all, for context, I think many listeners are aware that heating and hot water are by far the biggest energy load in homes, about 2/3, and most of that is actually for heating. And so as we transition homes from gas or fuel oil to heat pumps, that's obviously a good transition, and we're seeing that move happen increasingly, but it's driving additional cost to homeowners in many cases. It's also adding load to the grid. So what is Harvest doing is we're really addressing both those problems by giving those heat pumps the ability to fully load shift, not just for the hot water, but for that whole heating and hot water load. So combine a heat pump with thermal energy storage, combine it with thermal controls, enable predictive demand so that we can run the heat pump whenever electricity is clean, cheap, and abundant, for example, at noon, but deliver that heating and all that hot water at 5 a.m., 1 a.m., 9 p.m., whenever you need it. And it has some strong advantages, right? But I think the listeners are probably aware that heat pumps are actually very dependent on outdoor temperature in terms of efficiency. So if you can choose to run that heat pump at 11 a.m. or 2 p.m. rather than at 5 a.m., you gain an efficiency, which means that the homeowner, the ratepayer, pays less bills. And also at the same time, if you can use that electricity when there's often a lot of cheap solar electricity available on the grid, that also makes it more scalable from a grid perspective. So it's all about thermal energy storage, load shifting, predictive demand for the full heating and hot water load. And just for the audience, I think many of us are aware of the benefits of, say, smart thermostats that can do some preheating or pre-cooling. They can shift maybe 10% of the heating load of the house. Thermal energy storage, such as that implemented by Harvest, we can shift 90% of that heating load to whatever time of the day works best for the grid and the homeowner.
That is great. Those are impressive numbers.
Thank you.
Dave, what about you? What is the innovation that sets Daikin apart from others?
Yeah, thank you. So we look at really kind of two things that are a part of what we do. And I think just to start off, you have to really recognize that an HVAC product, a heating and cooling product, is a major energy user in a building or in a home. So you have to recognize that when you talk about the types of innovations that you as a company want to be in the forefront. So there's really two kind of areas that we focus, but the goal, of course, is to make sure that we provide that comfort to the user, but also address the impact, again, the energy use impact on the environment and to the user as well. So two areas where we have focused our energies in our innovation. Number one is what we call our inverter-based heat pump technology. And an inverter is a type of compressor. So all heat pumps, all air conditioners use a compressor that compresses the refrigerant, which is used for heating, for cooling, and for heating when it's in a heat pump mode. The inverter product is a variable speed product. Your typical heat pump or air conditioner is a single speed. It turns on and turns off. In the air conditioning mode, if it's hot in your house, it turns on, cools the house down, then it turns off, the house gets hot again, turns on, and so you have these kind of wild swings. An inverter-based or a variable speed system operates at infinite number of variable speeds. So if it's kind of mild outside, it may come on at 62%, or it may come on at 34%. That provides you with much better comfort, but also an incredible savings of energy because you're not using all of the energy necessary. You only use just what's necessary. But at the same time, and Jane had mentioned grid management or smart thermostats. This allows a utility to be able to manage the energy use in your home. In fact, in many cases, if there is an incident and the utility needs to lower the power use to your home, a single speed system has to turn off. It can't handle that lower power draw. But an inverter-based system could lower its power use. And in fact, you might not even notice that you're going through one of these incidents. So that's the first, and we really have focused on getting inverter-based technology out there. It's the standard globally in Asia and Europe. In the U.S., we're really trying to expand that. Number two is our low GWP refrigerant. We have used a refrigerant called R32, provides a much lower profile, climate profile, and with that, you get a variety of benefits. It can provide higher energy efficiency when used in a heat pump or an air conditioning product. Also helps you to manage your the capacity of the unit, and combined with an inverter compressor, you can actually reduce the size of the unit itself, which has a variety of benefits, but also can mean that you have less material being used and allow the cost of these systems come from the materials that are put into them. So those are really the two technologies that we have really focused our innovation with over the past couple of years.
Great, thanks, Dave. So one of the things that I like about both of the solutions that both of you have talked about is kind of the emphasis on flexibility, creating more flexibility and guaranteeing comfort and the services that people want in their homes, the heating, the cooling, the climate control. But you're not creating a brand new class of product to that's going to revolutionize the world and get featured on some science magazine. You are delivering these solutions that allow people to kind of use the things that they're already familiar with in a new flexible and innovative way, which I think is great. So Dave, Daikin's been around for a long time, obviously, as you mentioned, biggest HVAC company in the world, particularly with the inverter heat pumps. Kind of how did that product come to fruition?
Well, I think it is, again, through the understanding of the impact of these products, either on the individual consumer, the user, ensuring that when they operate it, first of all, they get the comfort. And as I mentioned, the variable speed provides that ability to really customize the heating or cooling that you're getting, but also the long-term energy use. I mean, when you have a system that in a very cold environment, a traditional system is going to be running at 100% capacity because it's on or off. So 100% capacity, it's drawing energy for a sustained period of time. Even if the temperature goes to goes higher, so it's not as cold, it's running that way. So we have really focused, our efforts have always been focused on, making sure you get that great value and comfort for you as the consumer, but also recognizing we, as Daikin, we've always felt that we have this obligation, and it's a kind of a broader societal obligation that our products do have this impact. We're not going to deny it. And so the technologies we develop, we can't ignore the consumer, of course, but we want to try to, what can we do to minimize that profile on the environment, again, while at the same time providing, again, that comfort. And those, the two areas that I mentioned do that and really address, we think, that the problems that we face today, and how do we bring down that energy use? And of course, we're constantly innovating, we're looking for new solutions, but this has been a solution that we really feel good about, that we think really can make a difference. And our efforts in North America have been to get more of these products out there. The more that we can get, more consumers getting access to them, they're going to love them. They do love them, the ones that do have them, but at the same time, see that the benefits, and we've talked to many utilities who love inverter technology because, again, it gives them that ability to manage their load, which helps them avoid crises, but at the same time helps with bringing down the overall energy use, which is also a priority for many of them.
Yeah, so it in a way helps on both sides of the electric meter.
Correct.
That's great. Thank you. Jane, so Harvest is, a little bit of a newer company. Can you share a little bit about how your product came to fruition?
Yeah, absolutely. The product essentially came to fruition from an awareness of the challenges of scaling electric heating and hot water systems. Similar to what David has been saying, the challenges in terms of capacity, the challenges in terms of the grid impact, and also in terms of costs that we've seen to homeowners. So I'm a veteran of both large companies and also a number of small energy startups. So that's my passion. How do you bring impactful innovation to market? And the freedom you have in a small company is the ability to think outside the box and figure out how can we do this differently, and how can we couple with the innovations brought by companies such as Daikin and others and help make them even better to bring that next generation on board. One of those is thinking, well, heat pumps are great, and it's great if we can modulate them and make them variable. That's a really great step forward. But can we go even one step beyond that? And just as electric vehicles, basically what are they? They're almost like computers on wheels. That's what they are. And what we've built is really a computer on a tank, turning that tank into a heat battery, a thermal battery. And so what that does is allows us to not just curtail energy, but to actually not run the heat pump and still deliver heat. Not run the heat pump and still have a boost capacity, allowing us, just as David, as you were saying before, to have a lower capacity heat pump, but deliver that high peak load that you might need at 6 a.m. or 7 a.m., which is when you get those peaks. So that's really what drove us, right? We have the freedom of innovation, which you get in a startup, a technology startup, and then that awareness, we come from energy backgrounds, HVAC backgrounds, policy backgrounds, that awareness and that desire to really figure out how do we scale this on a massive level. And so that's what it's all about, the controls, basically managing that thermal energy storage, doing the predictive demand, and doing that full load shifting to any time of day. I think increasingly we're seeing peak loads happening morning in winter. Historically, it's always been the afternoon in summer, and we're now seeing in some utilities already happening peak loads in winter, and that's progressing across the country. And that's a challenge that I think all of us working in the HVAC space are very aware of, and making sure we come up with solutions to be able to remedy that. And as particularly air-to-water heat pumps are beginning to come more into the US market, they've been present in Europe and Asia for a while, and they're beginning to come to the US market, that they're very powerful devices because they allow us to get even lower GWP refrigerants in the market, which is great. But they also come with it that natural ability for storage. And that gives Harvest the opportunity to work with more companies, more devices, and deliver this full load shifting.
Great, thank you. Thinking about that process a little bit of kind of this product coming to fruition and the development and scaling of these products, what has been the most significant obstacle that you've faced in getting to market? Jane, why don't we start with you?
Okay, thank you. So as I alluded to before, what Harvest is doing is we're taking a third-party air-to-water heat pump, combining it with thermal energy storage. And one of the gaps or the challenges, at least in the US market, has been there's been a dearth of air-to-water heat pumps, right? It's not been as commonly available as in other parts of the world. And as more become available, we'll be able to apply our thermal energy storage in partnership with those products as well. So that's something which has been a little challenging, but we're seeing that being resolved. Just at AHR 2 weeks ago down in Florida, you could see basically every manufacturer is really trying to step up and bring these technology to markets, in part because of their high performance, but also because they're very well equipped to work with very low GWP refrigerants. And it's probably a growth path in the future. So that's kind of been the major. I wouldn't say it hasn't been a hurdle, right? We've still been able to work with it, but it's certainly getting easier as more air-to-water heat pumps come in the market that we can work with.
Dave, what about you? What has been sort of the most significant obstacle that Daikin has faced in getting these innovations to market? I think either the kind of the inverter-based heat pump or perhaps the R32, if you want to talk about that.
Yeah, I think I'll just start kind of back up a little bit, just talk about heat pumps in general. And I think that, there's a perception issue, what is a heat pump? And I think that I always think back to the example, I used to work in the home appliance industry, and everybody knows what the refrigerator is, their dishwasher, clothes washer. And so years ago, the home appliance industry started making those products stainless steel and interesting colors. They made them kind of fun. Now, when you think about your heating and cooling, well, you don't think about it. You don't really, you think about what's making my house cool or hot. So when you say to people, you need a heat pump, they might say, well, don't I have one already? Or well, heat pump, that the name isn't actually very descriptive too. We've had that. So kind of a basic threshold issue is getting people to understand that a heat pump, what it is, and that it's a better way to heat and cool your house. So that's kind of the number one. Number two is, in terms of heat pumps too, there were some negative perceptions, or there still maybe are some. Many years ago, heat pumps came to North America, to the US market. They were different product. They didn't either operate as well in the colder climates. They weren't installed correctly because the people didn't have the proper training. And so there was some bad feelings towards them. So that's in the past. And today, the products coming out, they operate great in cold weather. They can go to very, very low temperatures. And if installed properly, you have a tremendous comfort, just great comfort. So I think that's those are some of those kind of threshold issues that we face. Now, in terms of getting inverter technology out there, again, those are products that take a little bit more in terms of their installation. They're a little bit more complicated. They have sophisticated electronics in them, so it takes a skilled contractor. And our job, as we see it, is to get those contractors out there properly trained and able to do that. In terms of R32, we have worked for many, many years to change building codes. And R32 is, we call an A2L refrigerant, mildly flammable, very safe, but it can, it does have this mild flammability. And so changing building codes and making people feel comfortable that they put that in their home, that everything is going to be okay, which it is. So I think those are some of the issues we face. So, training, really awareness of the product, and just making sure that people see this as the solution that's going to make a huge difference in their lives in terms of comfort, in terms of their energy bills, and overall just a great way to move forward, we see over the next 10 years.
Great, thank you. Jane, same question to you. Kind of what has been I'm sorry.
Take your time.
Sorry, I actually wanted to sort of jump off of something that Dave just mentioned. So Dave, you were saying a little bit about how there have been a lot of misconceptions over the years. Primarily, I think we were talking about like among installers or among consumers. But I'm really curious, what are some of the biggest misconceptions that you have encountered, particularly around like from policymakers or from those or from other stakeholders?
Is that for me?
Yes, please.
Yeah. Okay. Yeah. So first of all, I really appreciated David's answer there. Awareness is really important. I'd say one nice thing is we seem to be getting over that hurdle, and that we're getting a lot of heat pumps being installed now, and that's growing. So that's a good thing. But there's still a lot of learning. And I'd say there are a couple of things I'd like to bring up regarding things that maybe policymakers need to be aware of. One is what is possible, right? We're always aware of what is and not necessarily what's possible, what's coming to the market. It is totally possible to fully shift not just hot water, but heating load. And that is something that can be done. That can have a huge impact in terms of grid impact and also in terms of affordability and scalability of the systems. That is a game changer because it's the biggest energy draw of the house. And so that is something that is quite new. It's only just emerging into the market, but I think we're going to see more and more of that over the coming years. And then I think there's also a lack of awareness of the potential of air-to-water heat pumps and their benefits. It hasn't, as you mentioned before, it's not something which is yet as widespread in the US as it has been in Europe and Asia, although that is growing. But I think that lack of awareness can have negative consequences, because unintentionally what can happen is often you see programs, rebates and other programs that set efficiencies that are only designed around air-to-air heat pumps, and which unintentionally effectively precludes air-to-water heat pumps from participating in many cases. And that need not be so. I've seen programs in California, New York, in Vermont and other states that really avoid that pitfall and enable air-to-water heat pumps to compete fairly in those markets. And there are ways around it, right? There are The Energy Star emerging tech specifications do provide standards for air to water heat pumps that allow them to participate in these types of programs. So it's more an awareness, right? When you think about putting in place a heat pump program, think not just of what is, but think of where the future is going, and design your program so that you're not preventing the new and better technology, or at least very good technology, to also participate.
That's a great point. That is something that we think about a lot about, in terms of how are we ensuring that policies are inclusive of these important solutions, including maybe ones that we don't, maybe emerging ones, but also maybe even ones we don't know about yet.
That's right. It's really hard for you to know what's coming, and there's such a long cycle to policy. That's why this type of event is really important, to allow us to have this conversation about what's coming next.
Dave, same question to you. Or perhaps Jane mentioned a little bit about, like, not just misconceptions, but also examples of leading areas where we're seeing people kind of counter these misconceptions or encouraging these, like, new innovations.
Yeah, so I think one of the points that Jane mentioned was incentives, and I think that when you're talking about these new technologies, as I mentioned, the training is important. Installation can be different, can be not widely known, and sometimes there are some additional upfront costs. And so for us, we've really focused on finding those opportunities for incentives, whether they be at the federal level, state level, local level, utilities, and really getting these technologies in the hands of disadvantaged communities or lower income communities. And that's where we think there could be really tremendous benefit for those that will see really very, very strong benefits in terms of, besides their comfort, energy savings. And while you sometimes have, and this is the traditional problem, a larger upfront cost getting them into your home, once they're operating, those savings over time are just really tremendous, and you see that. And so that's again another area where we look at. And so again, combining this, getting this awareness out there, and there are a lot of really good incentive programs out there. Some of the states like New York, California, a number of others have really strong incentive programs, and that helps you to get past that initial part. One other thing I'll just mention is that, with this awareness, it's not just the consumers being aware, it's the installers. In North America, in the United States, we have something called two-step distribution. So Daikin sells to a distributor, the distributor sells to the installer. And the installer is the one that has, we call the kitchen table conversation. They come to your home and they're sitting at your kitchen table and they lay out all of the products that they sell. And well, they're going to present what they feel comfortable with, what they feel like they can install in your home. If they don't understand a heat pump product, they may not offer it. They may offer you a traditional system. And so you, as the homeowner, as I mentioned, you don't really know, you don't think about your heating and cooling. And so you just accept what they have. And so we have to get consumers demanding it, or asking for it, I should say. And then the installers suggesting it and saying, well, here's a great option for you. And then combine that with incentives. And in the past, there were federal tax incentives. There are still tax, and actually this year there are under the IRA, there are federal tax incentives. And at the state and local level, there actually are rebates, which are very, very powerful. In some cases, they can add up to sometimes half or more of the cost of that installation.
Great. And just as a little plug for Buildings Hub, we do track federal, state, and major utility incentives across many of the states. So if you're interested in those, we have a lot of information on all of that. But thanks to you both. We're just about to run out of time. So for our last kind of lightning round question, I want to ask you, flash forward to 2035. How has the U.S. heat pump market changed? Jane, why don't we start with you?
Okay, first of all, most homes use heat pumps. The refrigerant transition will have driven that change towards air-to-water heat pumps because it allows you to have things such as propane without bringing it into the house. So air-to-water heat pumps are going to be a major part of the market. And because of the nature of air-to-water heat pumps, they work really, really well with thermal energy storage. I think that's going to become ubiquitous because that's how you reduce bills, operate efficiently, and be super grid friendly.
Nice and concise and succinct. I appreciate it. Dave, what about you?
I think Jane said it very well. I see the same thing. I think we're really moving towards expanding that share of the market where heat pumps exist now. And I didn't mention air to water technology. There's a lot of opportunities there. It's not just heating water for potable water. It's also heating the home and providing radiant heat and other types. So I think there's all those opportunities there. I really do think that we're going to see a transformation of how we condition our homes, because with this new technology, you can get so much better conditioning combined with better insulation and better windows. And these technologies are really going to make people's lives much better and you're much more comfort, but at the same time, really positively, I think, impacting the environment. So I think there's a bright future for this technology.
That is great. A wonderful, sounds like a great future for all of us. So thanks so much to both of you for being here today, and thanks to our audience for joining us. You'll be able to find a recording of this episode and any of our past episodes anywhere you get your podcasts: Spotify, Apple Podcasts, on YouTube, and check out atlasbuildingshub.com to read our digests and data stories and to join our community. Stay tuned for a new episode of Buildings Hub Live soon. See you next time.
Thank you.
We hope you enjoyed this episode of Buildings Hub Live. You can listen to this episode and all other installments in our podcast on the Atlas YouTube channel, as well as on Spotify, Apple Podcasts, and Google Podcasts. If you're interested in additional content, check out our data, articles, and dashboards on Buildings Hub at atlasbuildingshub.com. Thanks for joining us, and we'll catch you again soon. We hope you enjoyed this episode of Buildings Hub Live.